Okay, we're going to try to solve this. So what do we get? We're given t. That's the time to hit the ground, right? And it is dropped, and that means VO is equal to 0 for this part. And what we're looking for is height. And this is where a lot of people made mistakes. See, in both cases, determine the height is for both. And there's a case 1, a case A, and a case B, right? So let's write that down here in the given. Case A, case B. Okay? And here we have t is equal to 20 seconds. And VO is equal to 0. And here t is still 20 seconds. And VO is equal to 50 meters per second. So we should circle that and say that that's VOB. And this one is VOA. Right? A and B. Okay, and what is required? In both cases, it's D. In A, D for case A, which is in meters, when VO is equal to 0. And B, still D, in meters, when VO is equal to 50 meters per second. Okay, and what's our basis? Our basis, since we're looking for D, is D is equal to DO plus DOT plus 1/2 GT squared. Okay? Okay, and so for problem, so that's the one you put right there. So this is the solution. Yeah, once you have it, that's what we're looking for. So dA is in meters is equal to, you can write the whole thing first so that you don't confuse yourself. Okay? The idea of a good solution is that you can follow it yourself. So for case number A, DO is 0, VO is 0, right? So you're left with D in meters, 1/2 GT squared. And you're given that 1/2 9.8 meters per second squared times 20 seconds squared. So this cancels with that, and you're left with meters. And the answer is, I think, let's see, exactly 980 meters. That's the DM. Okay, that's the first part. The second part is the same. This is A, and this is B. Okay, again, you write the same thing because you're looking for the same thing, but the conditions have changed. So it's better to write the whole thing over again. 1/2 GT squared. Okay? And then this is 0, but this is no longer 0. Okay? It's 50 meters per second times 20 seconds plus 1/2 GT squared. Okay, here's the thing. That V is not going in the same direction as acceleration, right? Because if you diagram that, the VO is going up, the acceleration, G, is going down. And so they have to have different signs. It's up to you which way you want to put it, but I think it makes more sense to make this negative. And so we have what? 1,000, negative 1,000 meters minus, then this is exactly the same as that because that's the same. So you just write that down. Oh, sorry. That's 1,000. Okay. Right? Because that's 20. Yeah. Okay. Meters. And then you have This is plus, this is 980 meters. Okay, here is where you have to think about your answer. Is that correct that when you just drop it from rest, it falls further than if it were going up? Yes. Right? Because what happens is the balloon would have to be closer to the ground, right? If in 20 seconds it would fall now from a higher height. So in this one, let's say the balloon is here. It's 1,000, almost 2,000 meters high. Here, the balloon starts lower and then goes up because it has a velocity, right? 50 meters per second. Okay? Hope that makes sense.